So far, in the denominators that we've wanted to rationalize, we've had a single radical term and nothing else. But what if we see something like this? In this expression, we have a sum in the denominator, which includes a radical. And we need to come up with something to multiply this by, where we'll end up with a root 5 squared term, but no root 5 term. And that's going to be somewhat tricky, because remember, when we multiply sums like this, we treat them like any other binomial. What comes to our rescue is remembering those special forms that we have available to us. If we multiply a sum by the corresponding difference, right, so change the addition to subtraction, otherwise we have the same thing. Well, when we multiply those, the product is a difference of squares. We initially learned this to help us in factoring, but it's also helpful to us here, because this means if I multiply 2 plus root 5 by 2 minus root 5, I'll get 2 squared minus root 5 squared, which will be 4 minus 5 is -1. This gives me a plan. I'd like to multiply my denominator by 2 minus root 5. Whatever I multiply my denominator by, I have to multiply my numerator by the same thing. And now, in my numerator, I distribute. And my denominator, I already worked this out, I get -1. Or, simplifying that, I've just got -6 plus 3 root 5. Let's confirm that that actually worked by entering both of those on the calculator. So my original fraction was 3 over 2 plus square root 5. And the final answer I got was -6 plus 3 square root 5. And we can see that those are, in fact, the same irrational number. Right? We got the same decimal either way. So how do we decide what to multiply by? We have these 3 special forms that are relevant to our interests here. Namely, the difference of squares, the difference of cubes, and the sum of cubes. So if we have a minus b, and we want to square both of our terms, we'll multiply by a plus b. If we have a minus b, and we want to cube both terms, well, then we'll want to get a cubed minus b cubed. So we'll multiply by a squared plus ab plus b squared. If we have a plus b, and we want to square both of our terms, we'll multiply by a minus b. And if we have a plus b, and we want to cube both of our terms, Well then, we'll multiply by a squared minus ab plus b squared. And what do we get in each of these cases? When we square both terms, we'll end up with a squared minus b squared. If we start with a minus b, we'll end up with a cubed minus b cubed in this case. Here we'll have a plus b times a minus b is a squared minus b squared again. And here if we have a plus b, we'll get the sum of cubes. So we'll have a cubed plus b cubed. So let's see an example, just using this for reference. Suppose we want to rationalize the denominator in this fraction. Well, currently in our denominator, we have a cube root of x. Right, so we want to cube this. So we have a minus b, and we want to cube. Well, we really want to cube the first term, but the second one comes along for free. So we want to multiply by something that looks like that. Okay, so we want cube root of x squared plus cube root of x times 2 plus 2 squared. So that'll be cube root x squared, it just looks nicer to write it that way, plus 2 cube root x plus 4. So I'm multiplying my denominator by that, and I have to multiply my numerator by the same thing. So in my denominator I'll get, let's see, cube root x cubed, that's just x, 2 cubed, that's 8. In my numerator, I'll have, let's see, 5 times that first term, plus 5 times 2 is 10, cube root x, plus 5 times 4 is 20. And now we have, as we wanted, no radicals in our denominator. I'm going to give you one of these to try now. Rationalize the denominator in the expression 2 plus 3 root 5 over 3 minus root 5. Pause the video and try this now. Okay, so in my denominator, I have a root 5. Right, that's the square root of 5. So I have a difference, and I want to square both terms. So that means I need to multiply by, okay, I've got the same two terms, but adding, not subtracting. So that's going to give me, I want to multiply my denominator by 3 plus square root 5. And whatever I multiply my denominator by, I have to multiply my numerator by that same thing. So in my denominator, I'll have 3 squared is 9, minus root 5 squared is 5. In my numerator, let's see, I'll have 2 times 3 is 6, 2 times root 5 is 2 root 5, 3 root 5 times 3 is 9 root 5, and then 3 root 5 times root 5 is 3 times 5 is 15. So combining my like terms then, in my numerator I have 21 plus 11 root 5 all over 9 minus 5 is 4. And I might wonder, can I simplify that at all? But it turns out that no, I can't simplify that, right? The only factors in my denominator are 2's, and I don't have any factor of 2 in my numerator. So that's what I get when I rationalize that denominator.